The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone, and welcome to XBOSoft's quarterly webinar. This quarter we have Robin Goldsmith, and he's going to be talking about proactive SQA measures, overcoming traffic cop resistance. And the hashtag today is ShiftLeftQA, and the reason is because a lot of what Robin is going to be discussing is how to take QA out of the end and being the gate and being the bad guy, and shifting a lot of our QA work to the left and doing more up front. So, Robin, if you can go to the next slide, please. Okay, so just a little bit about XBOSoft. We were founded 12 years ago now, and we do two things. One of them is QA consulting, and the other one is software testing, focusing on those three things there: automation, performance, and security. Just a couple house rules to start off with. All of the participants are muted except for Robin and myself. But what we'd like you to do is add questions into the question panel in the GoToWebinar control panel, and we can answer those as we go. And if we haven't answered them during the presentation, we'll answer them either at the end if there's time, or if we don't have time, then we'll put them in our blog. And of course, you'll receive information about the recording for the webinar via email as a follow-up within 24 hours. Just a little bit about myself. I'm the CEO of XBOSoft. I founded the company 11 years ago, and I enjoy cycling and travel, and that's pretty much my passion. But really today is about Robin. I'm really happy to have Robin here. Robin, how you doing there?
I'm doing fine so far.
Okay. Robin is kind of a famous guy in terms of really working deeply in requirements. And as you know, requirements are the guilty party as far as the cause of defects. And we tend to spend a lot of time talking about it in terms of how requirements cause a lot of defects, but I think that not enough attention is really given to requirements, and that's one of the reasons that we invited Robin for this quarter's webinar. Is Robin is really an expert in requirements, so we're really glad to have you here, Robin, and I'll let you take it away.
Thank you much. So, of course, Phil has started me off by calling me the guilty party.
Yeah, well, guilty and an expert.
Guilty as charged. Okay. So speaking of guilty, I'm wondering if anybody is familiar with QA in the role of traffic cop, typically enforcing compliance with things like document formats and making sure that procedures are followed, and often perceived as an obstacle to progress and an obstacle to delivery. And because of that, I think it's understandable why QA so frequently encounters resistance. And let me guess that those of you in attendance are here in part because you are familiar with that resistance and you find it frustrating, and you know, that's what we're going to try and give you some ideas on. So, yeah, the fact is that quality assurance functions are at risk. There's certainly resistance to QA functions that are perceived as being traffic cops. There's always the issue of whether QA is providing needed value. And there are issues such as whether QA is even doing QA, and many QA groups are not. A lot of QA groups get into trouble because they try to do everything themselves, and very often that means getting into things that they're really not qualified or skilled at. And overall, a lot of QA groups lack credibility and especially influence. And the two are related, but you can lack influence and still have credibility. But if you lack credibility, it's real hard to have influence. And these days, especially in Agile, there's a lot of Agile folks that think that QA is simply irrelevant, that stuff that can be handled just by doing Agile and putting things on the Agile project team. So I'm going to suggest that there is value, important, significant value that QA could and should add to the overall project and development processes. And that when organizations don't understand how to do QA appropriately and effectively, then they're missing out on that value. And one of the reasons they're missing out on that value is because they may not really appreciate what that value could be. And sometimes that's because the QA folks don't really understand some of that either. So I'm going to try and give some more guidance here. So we want you to be able,
Robin,
yeah.
Sometimes there's no really official QA role though, right? In Agile.
Well, that's exactly the point, that Agile often, when organizations consider themselves Agile, they often do away with explicit functions like QA. And that, of course, that varies with the organization, but it certainly is not an unknown thing that Agile has created additional impediments to the QA function. Okay, and what I've seen, and I suspect you've seen it as well, Phil, is that I've seen lots of organizations that, in the name of Agile, relied entirely on the developers to do quality assurance and testing, and not too long thereafter, many of those organizations changed their format to, in fact, bring explicit QA and testing people into the projects, because they find out that the developers just really, that wasn't their focus. And especially for system testing and special testing, things like security and performance and so forth, a lot of that requires specialists, and many organizations have shifted a bit, but there are still many that really have gotten away from having identifiable QA functions. And I think that that's possibly indicative of the fact that the ones that what they did have maybe were not doing as good a job as they could have or should have, but it's also because some people probably had some expectations that may or may not have been valid. So does that fit with your experience, Phil?
That's for sure. Sorry to interrupt you. I'll let you keep going.
Yeah, no problem at all. So we want to make some distinctions among some key terms. Okay, the quality assurance, quality control, and the difference between system and software quality. And we want to look at conventional QA, and especially as represented by an IEEE standard that's pretty prominent. And I think that when we look at the standards, then it becomes, and the standards represent what's in many instances widely accepted conventional wisdom, if you will. And when we look at what people think QA is, it becomes easier, I think, to understand why it's resisted or ignored and why it often just does not succeed. And then I want to introduce you to what I call proactive software quality assurance. And there are 6 functions of proactive software quality assurance. And I think you'll be able to see that when QA provides these 6 functions instead of the traffic cop, that people are much more likely to say, hey, that's really something that would be helpful to me. Let's have it. And so we'll focus on one of those functions, but that's where we're headed. Now, I mentioned standards. Some of you may be familiar with IEEE. IEEE is a professional association of over 400,000 members worldwide. And one of the things that IEEE is most widely recognized for is forming working groups to develop standards on a variety of things related to electronics and electrical engineering, including information systems and including quality and testing activities related to information systems. And so the first one of those standards that dealt with information systems was 730, which was developed in the earlier to mid 70s. And it was on software quality assurance plans. And that standard stayed essentially the same for 40 years. And in 2014, a significant, actually a total revision of it was released. And I was fortunate to be a member of the working group that came up with this total revision. I'll talk a little bit about that. And I think it's safe to say that proactive software quality assurance indeed was a major influence on a lot of those revisions. I know it because things got in there that wouldn't have gotten there without the influence of Proactive SQA. And I think that you can take advantage of these with or without actually referring to the standard itself. So we want to talk about definitions and why they're important. We want to distinguish QA from QC. We want to look at what traditional views of quality assurance are, and in many instances, that's the traffic cop. And then I want to introduce you to the key elements of proactive software quality assurance, and hopefully you will find that it would be something that might be beneficial in your own organization. So if you would type in the chat box what your definition of quality is, and what your definition of system quality is, and what your definition of software quality is. And I'll try to monitor on that, and I'll kind of chatter while you are typing that. So do one at a time: quality, system quality, and software quality. And you know, we're doing this to try to get kind of a grounding, a foundation, a starting point, get some ideas about what people think, see if everybody has the same definitions, see if indeed there are different definitions, why that might be, what those differences are, and see whether people make distinctions between system quality and software quality, and if so, what are those distinctions, and are they consistent, understandable, meaningful, and so forth. So hopefully we're going to get some responses here, because this is going to go a lot better with your participation. So one of the issues, of course, is if we're trying to assure quality, it's real important that we have some idea what quality is. And not only that we have some idea, but that others share our ideas. So if you would, type your definition of quality.
I see that one attendee, Melissa, typed in that she thought that quality means constant improvement.
Constant improvement, okay. Good. And thank you, Melissa. And anybody anybody else, please? It will be helpful to everybody to find out your definitions. They may be better than mine. I wouldn't be surprised, but we can't know that without your contributions.
Okay. And she also wrote in about system quality meaning better functionality and navigation and flow and how everything is connected. Then we've got Steve writing in saying that quality is a degree of excellence subject to standards, certain standards. But
okay, degree of excellence subject to standards. Good.
Andrew says quality means well functioning with good integrity.
Okay.
Good. Another one, Melissa says that software quality is better functionality for the user, how they access their most used items.
Okay. And so, what did she say? Better access for the users?
Most used items.
Most used items. Okay. Good. So, any others?
There's another one here. Mohan wrote in that quality means stability and low production issues.
Stability and low production issues. Okay. Good.
Okay.
Okay, so we've got some answers there. I'm not sure anybody made a distinction between system quality and software quality, but that's okay. So let's examine this. We had several definitions of quality, and while they were all related, they were by no means identical, were they?
No.
So constant improvement and degree of excellence subject to standards, well functioning with good integrity, stability, and low production issues. Okay, so those are all related, but by no means identical. And so one of the things that we need to consider is what's the significance of people operating with different definitions. When people have different definitions and are not aware that other people don't share them or have somewhat different definitions, that's going to be the source of difficulties. So let me ask also for people to distinguish what quality assurance is and what quality control is. Okay, and thank you again for your passing those along. Apparently, I'm not seeing them on my screen. So if you would, please enter your definition of QA and QC.
Well.
Any takers?
No takers so far, but that's a difficult one, I guess. Assuring quality and controlling quality. I guess one of them is assuring means something as good as possible, whereas controlling is controlling a negative. So making sure that quality is above a certain level, perhaps.
Okay, that could be a distinction.
Yeah.
Okay. So once again, it's important to understand what we mean by relevant terms.
Right.
And very often, people don't use the terms the same way other people use them. Very often, they don't even use the terms consistently. You know, and one of the things that I encounter is that some people will use a definition for QA and other people will use the same definition for QC and vice versa. And so there's a lot of confusion in the community. And when there is such confusion, it just adds to the difficulties of those people charged with QA or charged with QC or charged with both of them. So do we have any other additional thoughts on what QA is, or any other thoughts on what QC is?
Yeah, we have a couple here. Andrew wrote in and said that QC is a method of driving or managing activities that can enhance overall quality. And then Melissa wrote in and said that quality assurance is a set of standards of reaching a certain percentage without errors. We've got Patricia that wrote in and said that QA is systems and features operating in a specific manner, whereas QA or QC is bits and parts that are correct. Or, you know, small pieces that are correct, I guess, of a particular piece of software. Andrew chimed in and said that QA is certifying that there's good quality in the final product or service. Melissa said that QC is monitoring for reported issues. And then we've got one more that Mohan says that QC is a system of maintaining standards in manufactured products by testing a sample of the output against a specification.
Okay.
A lot of stuff there.
A lot of stuff there, and once again, not consistent. Those definitions were certainly not identical from everybody, and the fact is that some of them sounded like the definitions for the other thing. So that's the nature of our industry. And when we don't have clear understanding, then we've got more causes of difficulty. So one of the things that is often raised is the difference between system quality and software quality. And people didn't really get into this, but in general, some of you may well come from organizations that have separate groups, functions, activities for system quality versus software quality. And that would be especially in manufacturing organizations, a lot in the defense industry make those distinctions. And essentially, the distinction is whether or not hardware is included. That's the main thing. So system quality includes both hardware and software, whereas software quality deals just with software. Now, there's a difficulty with actions that are based on such distinctions, because people try to put projects and programs and so forth into the system or software bucket from the very beginning. And the problem is that the determination of whether a solution includes hardware is not something that comes at the beginning. It comes downstream. That's a design choice. So if you are making assumptions, okay, initially about whether or not the solution is going to include hardware as well as software, well, that's going to impact and probably distort your requirements, okay? Because you're making judgments, you're taking actions based upon something that you expect to happen that may or may not happen, okay? And if people, think that hardware is going to be included and it turns out not to be, or vice versa, well, what's going to happen? What you build is going to end up changing, okay? And so we end up with problems affecting both the requirements and the design. And I contend that this is largely because this system versus software distinction is not relevant and not useful. And in fact, when it's made prematurely, which it often is, has a very good chance of creating more trouble than it's worth. So I don't disagree that there are hardware-related aspects to quality and quality assurance, but those should not be the drivers. Those should be downstream decisions, okay? So a lot of folks don't use the term quality control. But in fact, quality control, the most common form of quality control is testing, executing the system, sample data and so forth. Now, the question here is, and I hope you'll answer this in the chat window again, and Phil will pass it on, is quality the same as testing? And is there anything besides testing that quality involves? So is quality the same as testing? And if it's not, then what else is there besides testing that quality involves? Okay. So a lot of people probably don't think about this a whole lot, and they have a job of performing testing, and they may be called quality or quality assurance or quality control or whatever, and they may well think that quality is only testing.
So
are there other views?
So you mean quality type activities, including more than testing, I guess. And
okay.
I guess there's certainly a lot of those, examining requirements, examining test cases themselves, matching test cases to requirements. A lot of things that can be done before testing work is done.
Okay. Anything else that quality involves?
Possibly determining quality requirements, determining what, like you said, what quality is. Maybe quality means for some pieces of software 0 defects found or something like that, or maybe quality means that all of the automation tests ran and they didn't find any defects. Or
okay, so I assume that most of the people attending are involved in testing. And does the fact that the system or software that you're testing has passed all of the tests, does that mean it's high quality?
Well, Jan Peter says that quality involves reviews and reviews of processes. Jenny says that quality control is visual inspection, whereas testing involves actions.
Visual inspection versus actions.
Right.
Okay.
So Melissa says behavior and standards, or privacy and security standards, adherence to those.
Okay.
Steve says quality is passive, whereas testing is active, which is similar to the other feedback.
Okay.
Why don't you take that and digest it and see what you come up with there, Robin.
Okay, so once again, what are we seeing? That there's no single understanding of this stuff. And to some extent, it's probably because these are topics that we don't necessarily have occasion to step back and consider. We're so busy doing what we do. So some of you may be familiar with the phrase quality is free, which was actually the title of a book by Philip Crosby, one of the big total quality management gurus. And Crosby wasn't saying that you achieved quality at no expense, but that quality was the necessary thing that you had to end up with, and that he then referred to the cost of quality as all of the additional costs beyond those that were necessary to get the needed quality. And he broke those down into three areas: the costs of assessment or appraisal, so your QA or testing functions, for instance; the costs of prevention, and some people call QA prevention and QC or testing detection, okay? And the costs of failure. So what are the costs when the quality is not adequate? Well, those can be internal costs. Those are the ones that we tend to focus on, fixing programs and things like that, okay? And then there are the external costs. What's the impact of a quality lapse? So every day almost, it seems, in the news, we hear about some kind of a quality lapse. A lot of them have to do with security breaches these days. Okay? But in general, people in QA and testing tend to be paying primary attention to internal stuff, bugs in programs and fixing them. But when we look at this overall, the external impacts tend to be the more important, okay? So quality is free in that that's what we need to end up with. And anything that we do beyond that in the way of poor quality and catching it and fixing it, those are extra costs. And that's what Phil Crosby refers to as the cost of poor quality. So we had some definitions of quality earlier, and I've listed some of them you'll see here as well. So I've listed a number of common definitions of quality, and I want you to look at them and make some quick judgments about whether there are any issues with them. So somebody said customer satisfaction, I believe, earlier. Is customer satisfaction the same as quality? Okay. What do people think?
Well, Jenny says quality means keeping our customer up and working. So I guess that would be related to customer satisfaction.
Okay, so keeping the customer
up and working.
Is that what? Up and working? Okay. So that could be an aspect, and presumably satisfaction would be a result of that.
Right.
But the satisfaction is not the quality.
Mm-hmm.
Okay? Yeah. Okay. And could you have a customer who was satisfied by less than good quality? Of course. And could you have a customer who's not satisfied by high quality? Yes. Consider just for a minute family dynamics. Okay. And
no, we don't want to talk about my family. We can talk about your family.
Well, no, we're going to talk about some random other person's family, the people we see on television. Okay. So we all know people who are married to people that we cannot conceive why anybody would be married to them, right? I mean, and yet their spouse apparently is satisfied with this ne'er-do-well, right? And then the other side of it is the in-laws are never satisfied with the spouse of their darling child. So the customer satisfaction is not the same as quality. What about meeting or exceeding customer expectations? That's another common definition. Any issues with it? Okay, so if you type it in, okay.
Well, I mean, I think that all these things are definitely elements of reaching quality or attaining quality, and that the resulting factor of it, I guess. and it depends on the industry and who you're trying to please and the stakeholder that you're trying to please goes into definition of quality.
Well, that's true. Now, the question is whether meeting or exceeding customer expectations is the same as quality. And for instance, if the customer expects you to provide a terrible product and you provide a terrible product, you have met their expectations. If the product is even more terrible than they anticipated, you've exceeded their expectations. But neither of those things says that it's quality, just the opposite. Okay? Some people talk about optimization as quality. Okay? Some people say quality is value to somebody. Okay, what about these as definitions of quality? Okay. By the way, these are not identical, are they? Customer satisfaction, meeting or exceeding customer expectations, value, optimization. Those are considerably different things that somebody or another has declared is what quality is. So what about optimization? Is that quality?
It could be to some people.
Yeah, but in fact, optimization is optimization. Okay, it's an efficiency issue. It doesn't mean that you're optimizing with regard to or that you're optimally creating quality. Okay, and value, once again, people value stuff that's not quality, and they don't value things that are quality. Happens all the time. Okay, Phil Crosby, mentioned him a minute ago, one of the 3 total quality management gurus. His definition, conformance to requirements, is one of the most widely used. I'm sure a lot of you listening are familiar with this, probably use it yourselves. Now, examine it critically. Is there any problem or issue with conformance to requirements as the definition of quality? Okay. So, are you getting any quick responses there, Phil? Okay. Okay. So, this is widely held, but consider that most of us, and Phil was talking about this earlier, most of us are in situations where requirements are continually inadequate.
Well, that's
conformance to inadequate requirements is not quality.
Yeah, well, Jenny wrote in and said that requirements could be incorrect or interpreted incorrectly.
Exactly. So conformance to poor or wrong requirements is not quality. Okay, the requirements themselves have to be high quality before they can reliably lead to delivery of a product or whatever that has quality. Some of you may be familiar with W. Edwards Deming, another one of the TQM gurus, and his focus was on statistical information and lack of defects, and several of the attendees had definitions that related to things like lack of defects. Is lack of defects the same as quality?
Well, I mean, it's one part of it.
It's one part of it. If something has defects, that diminishes its quality, but simply lacking defects does not necessarily mean that we would consider the thing high quality. Okay. Some people may be familiar with Six Sigma. It concentrates on variation. So Six Sigma says minimal variation within specification is quality. So is there anything besides variation that affects quality? And by the way, could variation, in fact, contribute to quality? So innovation, which is often a part of quality, is a form of variation. Okay? If the specification is not right, minimal variation within a wrong specification is not quality. Joseph Duran, the third of the TQM gurus, says fitness for use. And this is also widely used, got a lot of attractiveness, but there are only two questions. Which uses and what do we mean by fitness? Other than that, okay, good definition. So what's the point? The point is that there are many different definitions that people use, including people with a lot of recognition and credibility, and those definitions are by no means identical. And when we look at them, each of them has issues. Okay, and so if all these gurus and so forth can't agree and make definitions that have problems, should we be surprised if us normal folks also might encounter a few problems? So here's some other definitions. So fits the specs, runs efficiently, doesn't blow up, follows standards, uses current techniques and technology, and is easily modified. Okay, I'm sure that that sounds very familiar to a lot of our attendees. Here's what some other people think is meant by quality. Does what needs to be done correctly, performs adequately, reliable, consistent, easy to use, supported quickly, on time, and in budget. So who would say this is what's meant by quality? Typically, that would be folks like us, folks on the engineering and development and quality and testing sides. Who would say this is what's meant by quality? That would be what? Users, the business. So which is right? Okay. Well, somebody's going to say both are right, and they are correct. So both sides are part of quality. And who needs to know that? Both sides. And when we don't know that, then we get pointing fingers. Now, which of these is more important, the left side or the right side? And quickly type an L or an R in the chat window, and Phil, you can do a quick poll there. Okay. If we get any answers there. Which is more important, the left or the right?
Well,
Getting any takers?
well, I think the right side's more important, but let's see what's going on here. Some people say left and right. Guess it depends.
Well, okay. Okay. Well, I'm going to agree with you, Phil. The right side is the more important. Okay. If the right side is not accomplished, the left side doesn't matter. The left side is irrelevant if we're not delivering the value to the business, to the users. Okay. Now, when we don't have common definitions of quality, then everybody confuses and disappoints all the other players because each has a different idea. The business people say that the development people don't care about quality, and the development people say that the business people don't care about quality. And there's just a lot of finger pointing and there's no agreement. So we need to get people talking the same way. Now, to help us with that, there is a concept called quality dimensions. And this is an old concept. These concepts have been around for at least 100 years. So I didn't invent them. And there are, in this, there are 3 quality dimensions. Quality of design, which includes identifying what's required. It's what's it need to do. and then that the design suitably meets those requirements, and that costs and benefits and schedules are accurate, and that trade-offs, and trade-offs are inevitable, have been based on adequate information. So the first quality dimension is quality of design. The second quality dimension is quality of conformance, how it's produced, okay? And the third quality dimension is quality of performance, and this is what happens after it's delivered, okay? Now, if we look back, quality of conformance is what QA and testing is primarily concerned with, okay? And quality of performance is often left out of the equation until after we get into production. In addition, there are what are known as quality factors, and some people refer to these as non-functional requirements, and I'll encourage you not to use that term because it's misleading. So some of these are exterior. That means that they're primarily of concern or importance to the user. Some of them are interior. They're more of engineering stuff. Some of them deal with futures like adaptability and maintainability. But some people say that this set of things is the quality requirements. And I'm going to differ with you because overwhelmingly, the quality that we're concerned with is the thing that it does, the functions that it does, not just the modifiers. Those are all relative, but that's not the same. So when we put these things together, we see that we have two variables or two factors, how well and how much, okay? And the how well tends to be captured in engineering standards, and somebody mentioned standards as part of their definition, okay? And that the quality of design relates to how much is done, how much is identified during analysis and design. Quality of conformance relates to what happens in development, and quality of performance relates to what happens in operation. So when we put all these things together, let me suggest a different definition of quality. So I'm going to suggest that system quality is the extent to which the system meets weighted and stated, implied, exterior, interior, and future real business requirements of all affected internal and external stakeholders, consistent with standards of design, workmanship, and performance. Now, that's a mouthful. And let me suggest that the shorthand version is the extent it meets real business requirements consistent with standards, and that the more of the relevant requirements which are met and the more demanding the standards are with respect to meeting them, the higher the quality. And so quality is absolute. It's an engineering concept. What varies is how much quality you get. And that's going to be governed by your resources, your priorities, and other constraints. Value is the perceived benefit of quality received relative to the costs of producing and receiving it. So quality control examines end products or products, okay? Typically for conformance to specifications, and dynamic testing or code execution is our primary means of testing. Quality assurance is concerned with the processes producing the products. And to a lot of people, that means examining intermediate products within the development process. And so in many instances, reviews of requirements and design are considered to be QA, whereas executing code is considered testing. And then there's also checking compliance of documents and procedures to standards and guidelines, and that's where the traffic cop role comes in. Now, I want you to realize that intermediate products and compliance are forms of quality control, okay? That is not QA. It's just dealing with different products. Okay, so when we look at standards, okay, IEEE has a standard 12207, which is its fundamental catch-all system and software engineering life cycle standard. This is the big one. And in it, section 7.2.3 deals with the software quality assurance process. And the standard says the purpose of QA is to provide assurance that work, products, and processes comply with predefined provisions and standards. Okay? And that's what historically and traditionally people call quality assurance, a compliance with predefined provisions and standards. That's the traditional and reactive definition. Now, this was the starting point of our total revision. We revised it in accordance with 12 aspects of QA that IEEE standard 12207 provided. Okay, want to highlight that there's a big attention to identifying and recording problems and determining adherence of products, processes, and activities to applicable standards, procedures, and requirements. Okay. In addition, okay, said we need to have a QA process established, and it's to assure that the products provide those, that the processes and products provide those things that comply with the requirements and adhere to plans. And the operative word there, by the way, is established. And this coordinates with additional compliance activities, verification, validation, review, and audit. Okay, and a plan for conducting this should be developed, and that's what the original standard 730 talked about. That was the extent of it. But in addition, there's other stuff. Now, I want you all to think about whether what was just described here under 12207 is similar to the way your organization considers quality assurance. I'll let you think about that while I continue on, because I'm going to suggest that quality results from three things: how well the quality is defined, how well developers implement it, and how well testers detect the defects that do exist. And I would suggest that the impact is greatest from how well the quality is defined, next greatest from how well it's implemented, and least impact is from testing. But when we look at effort, overwhelmingly, the greater effort is spent on testing, and the least effort is spent on getting stuff right in the first place, and then the developers are in the middle there. So I think you'll agree that in general, our efforts are out of sync with where the greatest impacts are on resulting quality. So when we get proactive, we need to look at three areas. We need to look at processes to make sure they're defining appropriate methods and techniques and assuring that they're used well and they get used in the projects. Okay? And ultimately, we do need to test the delivered products to tell how well those processes have been working. But the delivered products are not the processes. Okay? And the value is by far greatest with regard to process, the next greatest with regard to project, and the least with regard to product, the testing. Okay? So when we get proactive, we're trying to establish an environment that promotes quality, and it's a cradle to grave, conception through retirement, defining what to do and when and how to test it, addressing requirements and design and workmanship and management practices, and identifying ways to improve and prevent errors. But at the heart of all of these, indeed, are quality controls. So there are 6 functions in proactive software quality assurance. Okay, you remember traditional software quality assurance is reviewing compliance with predefined plans and provisions. So one of these 6 functions indeed is identifying the QA plans, what to do. Another is defining how to do it well, methods, practices, standards, making sure it gets done right, assuring quality controls of processes and products are done appropriately, maintaining quality records to keep track of things, analyzing from that data so we can learn from it, report on it, and then directing attention to improving quality, encouraging it. And so I think you can see that this is a considerably different approach from simply checking compliance with predefined plans and provisions, okay? Because if those plans and provisions are not suitable, compliance will not be valuable. So indeed, when we get to number 2, okay, we're talking about making sure that what people do is in fact suitable. And that's the part that was left out of the traditional QA. Now, here's another thing. Assurance is different from doing, and it is not the job of somebody with QA in their title necessarily to be the individual who does this personally, only if you've got relevant skills and knowledge. Make sure that people with relevant skills and knowledge are involved in doing these things and actually help people. So I'm going to drill down just a little bit into QA plans, because the QA plan is the project plan for QA, which is part of the overall project. And project plans look at things like tasks and resources and budgets and schedules. As I said earlier, that's the entire focus of the original IEEE standard.
I thought in Agile we don't have any project plans. We just kind of do one iteration at a time.
Well, that's true, but there are also, one can also conceive of that as a plan. You're following the same plan iteration after iteration after iteration.
Okay,
you've got activities in there that you're doing.
I do have one thing. You better plan on speeding up a little bit, because we're going to run out of time there, Robin.
Right, we're just about done. Okay, so the QA plan is identifying what you need to do to assure quality. Some of that stuff is common to all projects, some might be unique, and you need to balance it with the risks and the various constraints and needs, and you use that to monitor and control progress, okay? So traditionally, people sat down and they came up with a list of tasks that they thought they ought to do, and I'm going to suggest that you instead take a deliverables approach based on agreement of informed, involved parties. Agreement upon what it is that people need to do in order to create and maintain and operate products with suitable quality. Now, some of you may be familiar with the olden days when the military had their own standards. Their main standard was 2167. It was counterpart to IEEE standard 12207. They're no longer using it. But that standard was very detailed. For instance, just for the requirements analysis phase, they said you should have each of these documents filled out. It was an enormous high overhead. Okay, that's a lot more than most people are going to get into. Consider instead, maybe with, talking with people, people agree that this is the set of deliverables that is necessary to guide a project to reasonable completion and adequate quality. So at a minimum, you need to confirm that if people say this is what's needed, let's confirm that it's been done. Now, you can do that with a check mark, or you can get a little bit more rigor by simply having the date it's completed. That's helpful, but there's more to it. So let's also identify the applicable standard or rules or guidelines for doing each of these things. And let's also recognize who's responsible for these respective deliverables, and that there is a budget and schedule for each of them. And let's map the actual hours and delivery dates against that. Now, that's project control information, and project managers would be concerned about it, but it's also relevant to quality. That's part of quality of conformance. But it's not just that somebody's delivered something with a particular title. Meaningful quality assurance checks it to make sure it's right. And so we need to include, with regard to each of these deliverables, before it is accepted and we go to the next, a meaningful review of it. Somebody needs to be responsible for guiding that. It in turn, the review in turn, has budgets and schedules. Now, if a deliverable is delivered after the QA was scheduled to begin, that's on the development side. That's not the QA people's fault. If QA finds a deliverable that needs to be redone and revised and re-reviewed, that's on the development side. If QA takes longer than they planned, then that's generally on QA, except what's the most common reason? That we take too long because we're bogged down with defects. So I hope you've seen some distinctions between system and software quality, and I would say that they're generally irrelevant. The QA is concerned with processes, QC or testing is concerned with products. The conventional standards take a very traffic cop after the fact compliance view, and when we get proactive, we're helping identify what it is that will really produce quality, make sure that it's done and done well. So this is a list of courses and consulting that I do. The 3-day version of this 1 hour is coming online in a little while. It's in my near-term plans. And pack a lies about me. If you want, actually, we didn't really update the slides, but if you want to contact me for anything, go ahead.
That's a big pack of lies.
Pardon?
I said that's a big pack of lies.
Isn't it, though? Okay. So thank you, everybody. And Phil, if you have any other questions or anything,
I think that's about it. I think people are probably ready to take off, but I just wanted to remind everyone that there are quite a few resources on our website in terms of our blog and also the white papers, and that you'll be receiving a recording of this webinar or a link to the recording. And then also, you know, this is a quarterly webinar, and our next webinar is usually in the first week of the quarter, so that would be in the first week of April, and we'll be sending out a notice of that. So thanks very much, everyone, and we'll see you soon. Thanks, Robin.
Okay. Thank you much. Bye now.